All right, STAT1800, going to work on the next demo video for this lesson. So let's go grab it. Taking the same approach with this one as I have the previous ones. I've already worked through it, so the answers are there, but I will show you how to get the answers. So let's work on demo number one, lesson number 4. So I think there are 6 questions. Actually, there's 7 questions, so let's do it. So the first question has sample A, sample B. We're assuming normal distribution, so that's extremely important when we have a couple of data sets this small. Notice that the confidence interval is 90%, so we'll have to make sure that we keep that in mind. So I'm going to open up the full data set, open up in StatCrunch. And actually, for teaching purposes, I am going to go split screen like this. All right. So I can go ahead and see in the problem that I need a 90% confidence interval for sample A and sample B. So to do that, I'm going to go to stat, tstat, one sample with data. And again, I have 2 samples here, sample A and sample B, but it would kind of make you think that I go to 2 sample, but I'm not comparing the 2 samples. I'm constructing a confidence interval for sample A, independent of the confidence interval that I'm going to construct for sample B. So let's go with data, and I'm going to select both of these. And I come down to my confidence interval, and I need to make sure that I get the correct confidence interval for this problem, which is 90%. So I hit compute. Let's bring this over here. So I can see that I entered 3.2 and 5.79 because it tells me to round decimals to 2 places, and 2.86 to 6.14. Now, the next question says explain why these samples produce different confidence intervals, even though they have the same mean and range. Well, if you notice, look at the answers. It says because their sample sizes are different. Well, they're not. It says because the medians are different. Medians aren't used to calculate confidence intervals, so that's irrelevant. And the final one, because their critical values are different, well, both of them are a 90% confidence interval with the same sample size, so the critical values are not different. So B is the only difference. And you can actually go to summary stats and go to column. You can go sample A and sample B and just select the standard deviation. And you can see that the standard deviation for B is quite a bit larger than for A. So that explains the difference in the types of intervals that we get. All right, so next question. The next question pertains to calculating a confidence, 95% confidence interval. So I'm just going to keep this up and just go to stat, tstat, one sample. But this time we're going to run with summary because we don't have our 99, I believe it is, 99 members of a website. Yeah, we don't have our 99 scores. We're going to calculate this with the summary measures, the mean and the standard deviation. So the mean here is 1800. The standard deviation is given to be 200. And we have a sample size of 99. Select confidence interval. We need 95, which is the default. And so we hit compute. And what you can see is we have 1760.11 to 1839.89. Now, the next, interpret the interval constructed. A is not correct. So there's a 95% probability that the mean spending for all shoppers who are members of this website premium, this is not correct because of the population that they're describing. 95% of all shoppers, well, that's not what we're estimating. We're estimating the mean. D, the sample mean spending in 95% of all samples. Well, that's not what we're doing. Again, we're not taking a subset of our total samples and making a statement about those. We're making a statement about the mean. So it has to come down to either A or C, but because the way that they've defined the population, C would only be the correct answer. So with 95% confidence, the mean spending in dollars for all shoppers, what we're trying to estimate, who are members of the website premium program, is between the lower and upper limits of the confidence interval. So again, just um, identifying uh, the what the mean spending is all about. Sorry, got distracted. Looks like I'm getting a package from UPS. All right, question number 3. So question 3, we have a data set. So let's open it up into StatCrunch. It'll close out what we had previously. All right, so we need a 95% confidence interval, so we should be pros at this by now. So the 95% confidence interval is 6.32. As you see, I typed in, and 7.89. Now, the purpose of this problem was more about questions B, C, and D than it was actually calculating the confidence interval. So first of all, interpret the interval. So again, we're talking about confidence, right? So we conclude with 95% confidence that the population mean is between the low bound and the upper bound, or in the interval. None of the other three make any sense. Uh, First of all, this one, again, goes back to 95% of the samples. We're not taking a subset of our samples. We want to analyze all the samples. 95% of the sample data, well, that's just not true. And then conclude with 95% confidence that the mean amount in dollars spent for lunch at the fast food restaurant for the sample, well, that has to be included in our confidence interval because we use the sample data to create the confidence interval. If you remember, we take the sample mean of these 15 scores, and then we add and subtract margin of error to it. So it has to be within the interval because it was used to create the interval. So I'm 100% confident that the mean amount of the sample is contained in my interval because I used it to create the interval. Small sample, anything below 30. Remember, we have to have a population that is normally distributed. All this other stuff makes no sense. And then you just come in and choose the correct interpretation. All right, next question. We actually get into confidence intervals for proportions. So I have to go a little different option. So I come down to prop stats, one sample. I don't have my data, I have my summary. So the number of successes, remember that's the number out of the whole. So the whole is 400. We have 100 out of the 400 that have what we're examining. And we need a 99% confidence interval instead of a 95. So you can see that we get 0.1942. It says to round to 4 decimal places. And 0.3058. That's a pretty simple problem. All right, an advertising executive wants to estimate the mean amount. I'll tell you what, I am going to stop the video here and transition into this part after I get my document camera set up. All right, take care.